here's what we want to do. We want to find the local minimum of this f of xy constrained by this, 2x plus 3y equals 1. Remember how this works. And we want to do this using Lagrange multipliers. Now remember how this works. I'm going to name this constraint. I'll set it up as a level curve. Like that. And then we have, of course, our f of xy. And remember how it goes. It goes the gradient of f equals lambda times the gradient of g. And then once we do this, once we get these gradients equal, then we use our algebra to figure out what is the x and y that will give us that local minimum. So here we go. First of all, the gradient of f. Well, I take the partial with respect to x, and I get 4x plus y. Okay, that goes in the first component. The second component is the partial with respect to y. So that's going to be x minus 2y plus 1. And I set that equal to lambda times the gradient of the g over here, and I get 2 comma 3. That was easy. Now we set up our equations. So equation 1 is going to be 4x plus y equals 2 lambda. Okay, so I just took the first component from each vector and equated them. Then I've got x minus 2y plus 1 equals 3 lambda. And then finally, for the third equation, I put 2x plus 3y equals 1. I put the constraint. So here's what we've got. We've got equation 1, equation 2, and equation 3. Now, so at this point, it's just a matter of us using algebra. We just have to rely on our algebraic skills to find out what x and y need to be based on these three equations. Now, here's the approach I'm going to take. From equation 1, I'm just going to solve for y. So I've got 2 lambda minus 4x. No worries. Now I'm going to take that and substitute it into equation 2. So I've got x minus 2 times, now what y is, 2 lambda minus 4x plus 1 equals 3 lambda. Now I just need to see if I can simplify this, because what I want is I want to get x totally in terms of lambda, and I want to get y totally in terms of lambda. That's what I'm thinking about here. Now if you'll notice this part right here, I don't have y totally in terms of lambda. I have y in terms of lambda and x. Down here though, on this one, notice all that's in here, the only two things I have are I have numbers, I have x, and I have lambda. So that's where I want to be for x. Now, here's what I have. I have x minus 4 lambda plus 8x plus 1 equals 3 lambda, of course. And I just keep working with this now. So this is going to give me, this looks like an x here, but it's a lambda. Let me make that a little more clear. So now I've got 9x plus 1 equals 7 lambda. I just brought the 4 over. Now if I subtract the 1, I get that x is equal to 7 over 9 lambda minus 1/9. There. So now I've got x completely in terms of lambda. Well, now that that's done, I'll just, make a note of, be sure I don't forget that. I'll just put a little box around it. Now I'm going to take that and substitute it back in to right there for x. So let's see what we've got when I do that. Okay, here I go. I've got y equals 2 lambda plus, minus 4. Now it's time for what x equals. And x equals 7/9 lambda minus 1/9. Like that. Now let's simplify that just a wee bit. Okay, y equals 2 lambda minus 28/9 lambda plus 4/9. And we continue working with that just a little bit. I want to combine the lambdas. So this is 18/9 lambda minus 28/9 lambda plus 4/9. And this leads us to where we want to be, because this is going to give us a negative 10/9 lambda plus 4/9. There, perfect. Now, we have y totally in terms of lambda, and we have x totally in terms of lambda. So let's think about that now with this constraint up here. 2x plus 3y equals 1. Okay? So let's see what we've got then. We've got 2x plus 3y equals 1. Now, here's what x is. X is 7/9 lambda minus 1/9. And y is 18/9 lambda. Well, actually, I was looking at the wrong thing. Negative 10/9 plus 4/9. Okay, so this is what we have now. Okay, now let's see if we can work with this. Now I notice I'm going to factor out a 9 and just multiply through by 9. So if I factor out well, not a 9, a 1/9. In other words, I'm just going to multiply through by 9, and what I'm going to get is 2 times 7 lambda minus 1 plus 3 times negative 10 lambda plus 4 equals 9. I just multiplied through by 9 is all. Now, let me figure out what lambda is. So I've got 14 lambda minus 2 plus, well, negative 30 lambda plus 12 equals 9. And what I'm trying to do is solve for lambda, because if I know what lambda is, I can go back and figure out what x and y are. That's what I'm shooting for. So here I go. So this is going to be, let's see here, negative 16, I guess, negative 16 lambda. And then this is going to be plus 10 equals 9. And that means that lambda is equal to 1/16. Because I do the algebra there. So lambda is equal to 1/16. Okay. Now, if lambda is equal to 1/16, then we ought to be able to determine what x is and what y is. So let's go back and see. We've got that x is 7/9 lambda minus 1/9. Okay? So x is 7/9 lambda minus 1/9. See? Let me just make sure. Go back and look at it. 7/9 lambda minus 1/9. Yeah, perfect. Okay? So that means that x is 7/9 times 1/16 minus 1/9. Which, if we go ahead and do the arithmetic here, what we're going to get is, let's see here, this is 7 over 144 minus 112 over 144, I believe. And that is going to give us, let's see here, negative 1/16. Now, let's look at the let's look at y now. Actually, I wrote, let me see, let me make one change here. I don't know why I wrote 112. It's 16. Yeah, that's correct there. And that reduces to -1/16. Okay, there's what x is. Now let's go ahead and figure out what y is. Okay, so let's see here. Y, remember, was -10/9 lambda plus 4/9. So now we've got this. We've got -10/9 times 1/16 plus 4/9. And that is going to give us, let's see, I believe that is going to give us 54, let's see here, 54/144, or that reduces to, let's see here, 6/16, which is 3/8. Okay, so we've got x and y. We've got x is -1/16. So let's do this. Let's find out what this is. F of -1/16, comma 3/8. And if we put that back into our function, we're going to get 7/32. Just just plugging it back into our function. And that's an example of how we can go through here and use Lagrange multipliers.